I know that the mean, the median, the mode, those are all things that are really like widely used. I think you've heard those terms before. We're going to start talking about this number called the standard deviation, which you might not have heard before. So let's just talk about what that means. And before we even talk about that number, I'm going to give you two sets of data here. Okay, so our first set of data is comprised of, I guess, numbers that have just the ones place. And then this next set of data, well, that one's a little bit more spread out, right? They're both kind of centered around 0, but the one on the right has like bigger numbers. It looks like there's a wider range of values, right? Okay, well, if I wanted to find the mean of the first set of data, well, what would I do? Perfect, right? So I'd add them together, -2 plus -1 plus 0 plus 1 plus 2. I'd divide by 5 because that's the number of numbers. And I'll tell you, if you do that, you'll get that the mean is 0. Okay. Now we can do the same thing on the other side, right? We can add these up, -20 plus -10 plus 0 plus 10 plus 20. We can divide by 5 since there are still 5 numbers. And I'll give you that mean as well. That mean is also 0. Okay, yeah.
Wait, how do you know? You must have worked this out.
Oh yeah, I cannot do this in my head. I did this in my office. Okay, so we have two sets of data. They're both have the same number of numbers. They both have the same mean. The mean is both 0. The difference between these two data is how spread out the data is. That's really the only thing that's separating these two sets of data. The data on the left, well, these numbers are really close to the mean. They're really close to 0. And the number on the right, or the set of numbers on the right, those numbers are a little bit more spread away from 0, right? So it's a little bit more spread out. Okay, so the way that we describe this spreading out of data, we call it the standard deviation. These two have different standard deviations. The one on the left is closer to the mean, so this has a smaller standard deviation. I'm going to say stand dev. Okay, and the set of numbers on the right have a larger standard deviation. So stand div, because, well, it's a little bit more spread out than the one on the left. Okay, so basically, if you have a large standard deviation, the data is more spread out. If it's a small standard deviation, the data is really close to the mean. Okay, well, I guess I answered that question for you. I didn't realize I wrote this question on here. In the example at the top of the page, it looks like the one on the right has the larger standard deviation, right? So the one on the right. Okay, let's keep going. If you take a look at these two graphs, now these are two things that they're basically histograms, but they're not very detailed. So I didn't show the bars, I just showed the shape of the graph with the two lines. We've got kind of like a skinny and tall graph, and then we have the red dotted one, which is a little bit flatter and wider. Which one of these do you think has the larger standard deviation? The long one. Gabrielle, did you? Yeah, so you're saying the long one, meaning the wider one, right? And why would that one have a larger standard deviation? Raven?
Because it's more spread out like this way, so it's flat. Because it has spread out more down. Versus the one that's center range.
Yeah, right. If it's wider and more like flat, then that means that the oh my gosh, the data values are more spread out than like a really skinny and tall graph, right? So this one definitely should have a larger standard deviation. Okay, so basically when you think about standard deviation, you don't actually need the actual numbers to figure out which one's larger or which one's smaller. Usually when you take a look at a set of data, you can kind of tell which one is larger, which one's smaller, even without doing the calculations. Okay, let's flip to the next page. Now, there's a way to find the standard deviation. It's a number just like the mean, the median, and the mode. And the standard deviation actually has a formula that goes with it. But I find the formula really weird and confusing. There's a lot of symbols on there that just, I don't know. I feel like if you just learn the steps how to do it, it's a lot easier to do than memorizing the formula and interpreting it. So this is what I do when I want to find the standard deviation. Okay. I need to find the mean, okay? Because the standard deviation tells us how far away from the mean that we are. So the mean definitely has something to do with it. Okay. What we're going to do next is we are going to take each data value and we're going to subtract off the mean. Okay, so we're just taking all the data values, subtracting the mean away from it to figure out, okay, how far away is each data value from the mean. Part 3, basically when we subtract off the mean, you might get a negative number, and we don't like negative numbers because sometimes it takes away from the positive numbers when we're clumping them together. So to counteract that, we're actually going to square our answers, and that makes everything positive. So it makes the numbers a lot easier to work with. Okay. After you're done squaring, just add all those numbers together, and then you're going to divide that sum by the total number of values you have, kind of finding the mean. Okay. Finally, if you want to find the standard deviation, what you're going to do is you're going to take that number you just got. That number is actually called the variance. Okay. And you're just going to take the square root of that number. Okay. So the square root of the variance is the standard deviation. Okay. If that made any sense to you, good job. I think it's easier to explain these steps using an actual example. I think it makes things a little bit easier to find. So why don't we go up to example 1, and you'll see that these are the same numbers as the first example that we worked with today. We have -2, -1, 0, 1, and 2. Let's find the standard deviation and see what happens. Okay, first thing we need to do is to find the mean. We actually already did this on the last page. We took the numbers, we added them up, and divided by how many. And if you remember, that mean was 0, right? Perfect. Okay, so let's go to step number 2. It says for each data value, we need to subtract off the mean. Now, I'm more of a visual person, so instead of like doing it in my head, I like to set up a chart. Okay, so in this chart, the first column just has all the data values that I'm interested in. So I just listed them up on the first column. The second column is where I'm going to subtract off the mean. That's step number 2, right? So I'm just going to go through and take each data value and subtract off 0, right? Because 0 is the mean. Okay. So -2 minus 0 is -2, right? Okay. We're going to take 0 and subtract it from -1. We're going to take 0 and subtract it from 0. We're going to take 1 and subtract off 0 and get 1. 2 minus 0 is 2. Okay, so all we did is just take each number, subtract off 0. Oh, we got the same numbers, right? Because when you subtract 0 from a number, you get the same thing. Okay, once you're done subtracting the mean, the third step is to take each of our numbers and square them. Okay, so I'm going to do this. I'm going to take -2 and I'm going to square the whole thing. Okay, now what do I get when I square -2? 4, and is it negative or positive? It's positive, right? Whenever you square a negative number, you're always going to get a positive number because that's squaring. Well, what is squaring? What is that telling you to do?
Like, okay, it's double the number, so it's basically 2 times 2.
Yeah, right. So it's telling us to take the number and multiply it by itself, right? So if you did -2 times -2 in your calculator, those negatives would cancel out. And that's why you always get a positive number, okay? Now, the reason I tell people is if you square a number and get a negative number, Master Uwe will be upset. So you can either memorize one of those 2 reasons. Okay. All right, so why don't we square -1? Okay, -1 squared is -1. +1, good. Okay, 0 squared is 0, 1 squared is 1, and 2 squared is 2. Okay, so I'm just going to write a note here, okay? Just make a note in your notes, say no negative numbers here.
How is 2 squared 2?
It is not 2. It is 4, right? I'm sorry. Wow, today is a great start to the day, isn't it?
Yeah, okay, I was like, it's Monday.
It's President's Day. We shouldn't even be here, right? Okay, I thought you know what? I wonder. Nope, I don't have that picture. That's okay. I thought I had a picture of Master Uguay, but that's okay. All right. Okay, so we're actually done step number, let's see, step number 3, right? So step number 4 says we need to take all those numbers and add them together. Okay, so under this sum area, this is where I like to do it because it's right underneath that column. I'm going to take 4, -1, 0, 1, and 4. I'm going to add them all up together, and you should get 10. Okay, so that's what you get after adding everything together. Okay, so who remembers how to find that variance? What should I divide 10 by? Perfect, right? So the variance is very similar to finding the mean. You're going to take that sum and divide by how many numbers that there are. So this is the number of numbers. Okay, and if I divide 10 by 5, I should get 2. Okay, and who remembers how to get from the variance to the standard deviation? Not square, but square root it, right? Yeah, so to get from the variance to the standard deviation, all you have to do is take that number, take the square root. Okay, now on the test or quiz, just leave it. You can leave it like that. Some of you like typing in your calculator. If you type 2 and the square root of 2 in your calculator, you should get 1.414 or something like that. All right.
Or we could just leave it as.
Yeah, you can leave it like that. All right, so any questions on how I did example number 1? Perfect. Why don't you go over to example number 2? It's very similar. The mean is still 0 since we're trying to find the standard deviation of the other set of numbers. Why don't you work on that for a little bit and then we'll come back. Righty. So why don't we come back up to the front here? Very nice job as I've been walking around. Looks like all of you are doing the right things here. All right, so example number 2, the first thing we have to do is find the mean. Alexis, I guess we don't need to explain how to find the mean. I think we're all good here. All right, next off we have subtracting off the mean and squaring the answers. Michael, you want to take us through this one? Ish?
Yeah, I just took the number from the data nine subtracted by 0, which is the exact same number. So, and then squaring the answers, the negative numbers. Just get rid of the negative when you multiply by itself.
Perfect. All right, and then Sean, do you want to take us through the rest of it?
I added all the squared answers, and then 5 by 5 is 100. That's for
Perfect job. All right, any questions on how I got these answers? Perfect. Okay, now example number 2 and example number 1, they were pretty easy because, well, the mean was 0. The mean doesn't have to be 0. And before we go to the next question, which doesn't or has a different mean, let me just tell you something that I've noticed here, okay? So in the last example, we did the standard deviation of the first set of numbers that we worked with, and we get 1.414. In example number 2, let me just tell you what the square root of 200 is. It's actually 14.14 something. Okay, so I know in the beginning, we took these two numbers, we guessed which standard deviation would be larger. We said that the second set of numbers would be larger. It actually was larger, right? Because we went from a standard deviation of like 1 point something to a standard deviation of 14 point something. So there is a big difference in the standard deviation. It was a lot larger, right? All right. So why don't you give example number 3 a shot, okay? Example number 3 has a different mean than 0, so the calculations do get a little bit more wacky, but we will come back in a little bit. All right, so let's take a look at this example here. We want to find both the standard deviation and the variance here. We have 4 numbers this time, and who wrote up how to find the mean?
Oh,
That was it. I was like, I don't remember. Oh, Emma. I think we all know how to find the mean. It looks like everyone got that correct as I was walking around. So Emma did a great job of finding it. The mean was 2 this time, not 0. So next we had to fill out the chart, right? We had to subtract the mean and square the answers. Alicia did a great job of doing that. I don't think I need you to explain how to do that either. I think subtracting the mean and squaring them is pretty self-explanatory here. Just a little reminder, all your numbers here have to be positive. Make sure that they are not negative or Master Uwe will find you. And then, and then finally, well, Sarah did a good job of writing out the sum, right? After you find the sum, do you want to explain how you got the variance and standard deviation?
14 divided by 4, and then
Mhm. Perfect, right? So going from variance to standard deviation isn't that hard. I feel like it's very confusing. There's a lot of steps, but I think if you organize it this way with the chart and the sum and the variance and standard deviation, it's pretty easy to remember what to do at each step. All right. Any questions on finding the standard deviation?